Hello, today I will be doing a couple examples of finding the x-intercepts and vertex of some quadratic formulas. In this case, we'll have one example where you're able to factor and another case where you cannot factor, and you'll instead have to use the quadratic formula. So, starting with this first one here, and sorry if I'm a little bit sloppy with my mouse. I lost my stylus, so I have to use a backup stylus for today. So first, we have this quadratic here. We have x squared minus 8x plus 15. So the first thing you want to do is see if you can factor that. So we have 15. So we want to see if we have any numbers that multiply to add to 15. Multiply to make 15 or add to make -8. So I'm just going to list out some factors. So 1 times 15 makes 15. 3 times 15 makes 15. 5. Oh, sorry. I don't know why I did 3 and 15 there. 1, sorry, 1 and 15, 3 and 5, and sorry, yeah, that's all the factors. So does any of these add up to -8? Well, both of these were negative, and they're both multiplied together. They would multiply to make positive 15, and they'd add to make -8x. So that means y equals x minus 3 times x minus 5. And therefore, x equals 3 and x equals 5. To find that, you'd set it equal to 0. So 0 equals x minus 3 times x minus 5. And x minus 3 would equal 0. So we're setting each of these equal to 0 because each of these things multiplied together, one of them has to equal 0. So that means in this case, x equals 3, and then here we have x minus 5, 0, and x would equal 5. So now that we have our x-intercepts, one thing we can do is we can find the vertex. So the way we can find this is by adding each of these x values together and dividing by 2. The reason we can do that is because, do it a little bit bigger. In a quadratic, the zeros are, let's see. The vertex is exactly halfway between the two zeros. So if we add these two up and divide by 2, we can find the exact halfway point, and then we can find the x value of the vertex. So we're going to add these two together and divide by 2. We have 3 plus 5 over 2 equals, that'd be 8 over 2, which equals 4. And then we're going to sub that back into our original equation. So we have y equals, and what was our equation again? We have y equals x squared minus 8x plus 15. So y equals 4 squared minus 8 times 4. And what was that again? Plus 15. And that means our y value is at -1. So, and therefore, vertex at coordinates x equals 4 and y equals -1. And now we can graph our quadratic here. So just each of these ticks will be 1. Be a little bit sloppy. So we have our zeros at x equals 3. Here, I'll do a different color. X equals 3. And x equals 5. Oh, sorry. And halfway between those at x equals 4 and -1. So let's say it's about here. We have our vertex. There we go. And so in order to draw this, we would just connect these together. And It's not the best drawing, but it will do. If you are given a graph, one thing you can do is for if the coefficient on like the a value, so here we just have a 1, so you'd be going from your vertex, you'd be going over 1, up 1, and then after you'd be going over 2, up 4, over 3, up 9, etc., because you're squaring that value. And then one thing we can do, we can also check our answer. So I'm going to pull out my virtual calculator here. And so this isn't like a fix all for, like you can't just use your calculator and then draw your graph and call it a day. Like this is just a way to check your answer. But we are going to go into equation mode, go into quadratic. Our a value is 1. Then we have -10 for our b because we have oh wait, no, wait. Do we have -8 here? -8, oh my bad. So we had -8 for that. And plus 15. And we had x equals 5 and x equals 3, which is good. That's what we got for our x-intercepts. So that's good. And then we can scroll down, and for our vertex, we had 4 and -1, so that means we did that right. So next up, we have another example here. I'm just gonna try to move this over. So we can try the same thing. Let's try to factor it. So is there any number that multiply to make -19 and add to make -10? Well, 19 is a prime number, so the only things that multiply together are 1 and 19. So it does not look like you can factor it. But just for sake of example, another way to verify that you can't factor it is by finding the discriminant. So we know that the quadratic formula is x equals -b plus or minus a square root of b squared minus 4ac all over 2a. This b squared minus 4ac here, that is our discriminant, and it can tell us a lot of information about the function before we do any work. Say if that's negative, then we know that there are not any zeros, etc. But we can try that. So our a value here is 1, and then our b value is -10, and our c value is -19. So we can check our discriminant, and that will be -10 squared. And make sure when you're putting that into your calculator that you put the -10 in brackets, or else if you don't have it in brackets, your calculator will put it as -100 when it should be +100. It's a common mistake. Then our a value is 1, and our c value is -19. And let's see what that equals. So equals square root of 176, which is approximately 13.26. So since this is not a perfect square, like say this was like 64 or 9 or something, that would mean you would be able to factor it. But since this is not a perfect square, that means you'll have to use the quadratic equation. So we can start filling in our equation here. So yeah, we know x equals -b plus or minus a square root of b squared minus 4ac all over 2a. That equals -10. Make sure you watch those negatives. Plus or minus square root of -10 squared divided by 2a, which is just 2 times 1. Guess we can still write that. And then that means x equals, we already found what our discriminant is. That would be x equals -10 plus or minus the square root of 176. I'd recommend you keep this exact right until you do the calculation. So now we can split this apart into two different equations where we add square root of 176 and one where we subtract. So let's do, let's add it first here. Plus the square root of 176 over 2, and that will give us a value of x equals sorry about that. Equals 1.63, and then we'll do it for minus. So we'll have -10 minus square root 176 over 2. That equals -11.63. So that means our zeros are at 4 zeros at equals 1.63, and x equals -11.63. Now we can do the same thing as we did previously to find the vertex. Since we have both zeros, tomorrow I plan on doing some examples where we do not have zeros and we still have to find the vertex, and we'll find that using a method called completing the square. And so let's find our vertex, the x value. So we do, so it'd be, I guess it'd be x1 plus x2 over 2 would be the proper formula, which equals 1.63 plus -11.63 divided by 2, and that will give us a nice number of 5. So now I know our vertex is at 5, and now we can sub that into our equation to find the y value of it. So our function is, where is it? X squared minus 10x minus 19. So f at 5 would equal 5 squared minus 10 times 5 minus 19. And that will give you -44, and therefore vertex at 5, -44. For draw our graph, so we have an x-intercept at 1.63, so somewhere over here, and then 1 at -11.63, so it'd be over here somewhere, and we have our, oh sorry, in our vertex, sorry, this was supposed to be a -5, made a mistake there, and then our vertex will be halfway between those points at -5. Well, that's just the x coordinate. So -5, then -44. So it'll be like way down here somewhere. And then you just connect the points here. Yeah, sorry, it's a little bit sloppy. This stylus is not the best, and I'm not the neatest. But we can check that real quick on our calculator here. Just again, this is just to check your answer, make sure you got it correctly. So our equation is, so go to mode, equation, this is quadratics, we hit 2. our A value is 1, our B value is -10, and our C value is -19. And there we go. Those are the X values we got, and we found our, for our vertex, we had 5, -44, which is also correct. So that means we got this one right. So yeah, if you guys have any questions or concerns, please feel free to email me. It's a little bit difficult for me to figure out what you guys are doing and what you're working on since the notes aren't posted and I can only show up to a couple of classes a week. So if you do want me to cover any specific equations or examples, please let me know. I'd appreciate it. And yeah, I'll talk to you guys later.